Ask an AI agent to edit a document, and it may corrupt correct content. This episode gives you a screenshot-ready document delegation integrity checkpoint card. AI edits within a defined scope, while people protect the baseline, inspect every round, and decide whether to accept the result. In April 2026, Microsoft Research published LLMs corrupt your documents when you delegate. Its Delegate 52 benchmark tests whether correct content survives multi-turn document work. This is a preprint benchmark spanning 52 professional domains and 19 models. It exposes a long workflow risk. It does not mean every real delegation damages a document. The checkpoint card is our source-backed synthesis, not an official Microsoft template. This video is packed with practical, high-value insights to help you get better at using AI. It's a longer one, so follow Tiny Agent and save it so you don't lose it. Start with the counterintuitive result so you know why checking only the requested edit is not enough. Delegate 52 asks models to keep working on one document across a long workflow. Success requires both making the new change and preserving correct content that the request did not target. The researchers report that frontier models corrupted about 25% of document content on average by the end of long workflows. The requested change could land while unrelated material degraded. The errors were sparse but severe. Most pages could look normal while a few facts, numbers, citations, or logical links became wrong, making a quick read unreliable. That percentage is an average inside the benchmark. It does not predict that every contract, report, or plan will lose 1/4 of its content. Delegation creates a tempting shortcut. The agent says it is done, the edited paragraph reads well, and the reviewer never compares areas that were not authorized to change. Before work begins, people should identify protected content, key numbers, conclusions, citations, constraints, approval status, and sections that the task must not touch. Chapter Recap. First, completing the requested edit does not prove that the whole document stayed intact. Second, sparse errors are easier to miss than visible failures. Third, people define which correct content must remain unchanged before delegation starts. Next, separate the conditions that increase risk so you know when to shrink the task instead of adding another vague instruction. The first condition is document size. More facts, cross-references, and local constraints create more opportunities to fix one section while breaking consistency elsewhere. The second is interaction length. Each turn changes the working version. If review waits until the end, a small early deviation can travel through later edits. The third is distractor files. Irrelevant material dilutes the sources that actually govern the document and can pull similar but incorrect content into the result. These conditions compound. A larger document provides more vulnerable locations, a longer interaction accumulates more version drift, and distractors add competing evidence. The result may still sound fluent. A number can look plausible and a citation can look complete while no longer matching the original source. People should set takeover thresholds for document size, expected turns, and input file count. When a threshold is crossed, split the work, remove distractors, and add intermediate acceptance. Chapter Recap. First, larger documents are harder to preserve in one pass. Second, longer interactions allow early deviations to accumulate. Third, more distractors make source isolation more important. Now separate tool access from trustworthy results so you do not mistake capability for acceptance evidence. The study also reports that agentic tool use did not improve performance on this benchmark. Search, read, and write access did not automatically protect untouched content. Tools expand action capacity. They help AI locate, replace, and write back material faster, but they can also spread one mistaken decision across a larger area. AI is useful for bounded local edits, enumerating changed regions, tracing affected references, and rerunning deterministic checks. People define the target, editable sections, protected facts, and stop conditions. Without that boundary, tools only execute an ambiguous request more efficiently. Break a long document into independently reviewable sections. Give one edit intent at a time and require the agent to report every region it actually touched. Tool output still passes through integrity checkpoints, original baseline, scope confirmation, diff review, invariant checks, and human acceptance. Chapter Recap. First, tool capability is not document correctness. Second, AI performs bounded edits while people define scope and stopping rules. Third, broader write access requires stronger rollback points. Next, put acceptance into every round so you can catch a correct target edit that quietly damages something else. Save a read-only baseline and a recoverable version first. Without the original, a later diff cannot tell you which content was already correct. Create a protected content list covering numbers, dates, names, citations, links, table formulas, approved conclusions, and sections that must remain untouched. After each round, inspect the real diff. Ask AI to explain where and why it edited, but treat the file comparison as evidence and the explanation as a claim. Then run invariants, totals still balance, references still resolve, heading structure remains complete, and critical conclusions still match their sources. For contracts, finance, medicine, law, or public commitments, sample surrounding context, cross-references, and units. A spelling check is not enough. People accept the round only when the target edit is correct, unauthorized areas remain intact, and critical invariants pass. Otherwise, restore the most recent accepted version. Chapter Recap. First, a read-only baseline proves what the document originally contained. Second, diffs and invariants expose sparse but severe degradation. Third, people accept high-consequence documents and preserve rollback. Finally, turn the method into 6 checkpoints you can reuse before asking AI to edit a report, contract, plan, or knowledge base. Box 1 saves the baseline, frees the original, version identifier, and restore location so every edit starts from a comparable copy. Box 2 marks protected content, list facts, numbers, citations, constraints, and no edit regions that must remain unchanged. Box 3 isolates sources, provide only the files needed for this round and remove old drafts, unrelated attachments, and confusing lookalikes. Box 4 delegates by section, state one edit intent, allowed scope, and completion test, then require a report of every touched region. Box 5 checks the diff, compare baseline and candidate, then run invariants for numbers, citations, structure, and critical conclusions. Box 6 requires human acceptance. A person reads high-consequence context and approves the result. Any anomaly rolls back to the last accepted version. Screenshot these 6 checkpoints and use them the next time AI edits a document. Chapter Recap. First, freeze the baseline, protected content, and relevant sources. Second, edit by section and verify every round with diffs and invariants. Third, final acceptance and rollback remain human decisions. To summarize, ask an AI agent to edit a document, and it may corrupt correct content. Acceptance must cover more than the new request. It must also prove that previously correct content was not silently damaged. AI can make bounded edits, enumerate diffs, and run deterministic checks. People own protected scope, high consequence review, final acceptance, and rollback. What would you be most worried about AI corrupting in a document? Numbers, citations, conclusions, or untouched sections? Share it in the comments. Follow Tiny Agent. Tiny Agent helps you get better at using AI.